Our last example is a natural log data analysis. And of course, there are cubics and quartics, and you would just do it the same way based on what you're seeing. So same old thing, you're going to type this into y equals, or if you have a Casio, you're going to run, type it into table, and you're going to go to edit, type the information into L1 and L2, turn your plot on, zoom stat, and you get this very nice looking logarithmic model. Now, when you're in Desmos, one of the nice things about it is if you have information you don't need, you can just delete it out. You can also just click to get rid of it like that. And that is very nice how easy that works. You've also, again, this tabbing feature where you can type in and tab to the input and output values. There is no tab on a calculator. So it's a very good idea to learn how to do this, even if you learn you have to go back and learn on it on a TI or a Casio. It's just really good to be able to do that. Then you go to the wrench and you put in the information that you see. You know, this is going from, the domain of this is 25 to 1400. I'm going to put in 0 to 1400. It's always good to have an X and Y intercept. And on the y-axis, we're just going from 0 to 6 maybe, and then we can easily adjust it. Notice I also changed the x-axis to say decibel, which is the input, and out here I put sound factor for that. I could actually type the whole thing in if I wanted to. All right, so I undo the wrench and I see okay, so I'm going to come over here, going to zoom out a little bit. Nice logarithmic curve. Nice logarithmic curve. I get a nice label. Now, that goes to all the way to 1,000, so maybe that's the first time we use the step feature. Maybe on the graph, I wanted to actually label those, so I could actually say label those by 1,000, and I come out and it goes by 1,000. But if I wanted to do less, right, I could go by 100, and it would, when I zoomed in or zoomed out, it would, start doing that. Okay, so what model is this? Well, this model is y equals ln x, which has an a in front of it, just like you learned, ln x. I like to put that in parentheses. And then outside of that is the B, and that is the, vertical shift and the stretch. And so what I would do there is I would then say, okay, well, I've got to toggle the keyboard, get rid of the numbers, go into this piece, and put in the approximation and change this to match the chart. So I have a subscript of a 1 and then a subscript of a 1. And wow, look at that beautiful model. So what would we maybe want to call this? Well, again, we could just use the A and the B. If you had to write it down, you'd want to use these numbers. You have to actually write the numbers down on paper. Well, why don't we call this decimal, and then typically, for the factor, that's typically an N, like with sequences of series, like the number that you're hearing. Think of it like that. And then we would type in here L, A, L, N, X, but we'll use an N. And here we'll have a plus B, and it of course knows that, and you can see it modeled right over it. I can turn it off, and it goes back to red for this one. I turn it back on, it shows me that's the exact same model. And so the reason that we do all that is we have everything on our screen to start answering questions. So again, I always like to have you make a quick sketch. You always have to write it down, right? Write it down. And then the question is, well, what is a sound magnification that is heard of a decimal of 180? So if the decimal is 180, how much sound are you hearing? On the TI or the Casio, make sure you put your table set up so you can actually type this in. Type in 180. And of course on Desmos, if I have this ready and I've typed this in, all I have to do is say, well, that would be D of 100. What they say? They said 180, and it will show up the exact same answer. Now in this model, we're getting the exact same answer to the thousands place that we got on the TI. Or in the Casio. And again, some models are just a little more sensitive. Now, that being said, keep in mind the TI is going to produce, it's like it's backwards, right? So they say A plus B ln X when it really should be A in the front plus B out here. So it comes out looking backwards, and just keep that in mind. Also on purpose, I use different letters, but notice that those letters are the same as I have here with these numbers. Just notice that 0.94 is what we call first, and here we call that second. You just have to really pay attention to the different varieties when you take a test on this. People can do it in different ways. They can use different models. So just be aware of that. But they would still call this a natural log. So let's say a person hears a magnification of 3.5. You would graph that in Y2. find that intersection by running the intersection program. And on Desmos, what you would do instead is you would come down here, you would get rid of this question and just say, hey, where would D of n, or whatever I wanted. I mean, if you called it f of x, no one's going to really mind. I just am trying to get you to realize that different letters are sometimes used by other people. And so they wanted to know when this would happen at a rate, at a magnification of 3.5. And so all I do is just click right there, and you can see 113.155 is exactly the same. But, you know, here I have more control over what I do. I mean, if I wanted to make this model identical to theirs, I could, right? So I could come back up here to the TI. I have complete control over this and say, okay, well, the A, they have a plus here, and then they put a B here, and then that goes away. And then look, like everything's exactly the same. I mean, it's exactly the same. But the TI is what's really wrong here. Not really, right? So the nice thing about Desmos is you have control over everything you do. So if you want to make it look exactly the same, you can. It doesn't change at all this answer. Look, it's still 113. And if I go back and say, what was D of 180, it's still going to say that D of 180 is negative, hold on one second. It's going to be the same value. So just keep that in mind. The problem is here, you know, I didn't change this graph, so I would just need to rewrite that to model it. So I need to say A plus B, right? And then I would get the exact same answer. So, right, so now I get 3.962, just like I had here. So what's the better model? The better model is whatever your teacher says you have to use. The SOL allows you to use Desmos, and Desmos has so much more, it just has so much more ability to model what you want it to. So again, you know, the model that we would understand would be more like this, because of the fact that, well, we know about stretches, and we know about, you know, if I even wanted to call that a K, because that's what I called it in class, as long as I update this, it's fine, right? It gives me the same answer. So Desmos allows you to use whatever letters you want, which is awesome. And that's, you know, probably the wave of the future, is this flexibility. It also, I mean, imagine if you need to use this for a project or something, you could just screenshot this and put it directly in your project with you highlighting that thing. Easy to label, easy to deal with. So some teachers, you know, if you take AP Stats, you might have to use this calculator. I'm sure your teacher will teach you, but you can see that there's a lot of menus to use. And you do get the same answers either way. So it's really up to you. If you want to learn to use the calculator, you can. If you want to use Desmos, you can, or learn both. It's really up to you. But don't spend too much time. Find what you like and stick with it.